Right. So the last day we started talking about objects in JavaScript as a means of representing complex data, what I'm calling complex data, anything other than a primitive, essentially. And so we kind of got to the stage around here. Sorry now. Where we talked about objects being dynamic and the fact that we could nest objects. Dynamic meaning we could add properties or remove properties from an object after it had been declared. So I just need to keep checking that I'm audible. Yeah, I am. Okay. That we could add or remove properties after an object has been declared. And in terms of objects being nested, the idea there is that one of the, or a property within, or many properties within an object, the values could actually be objects themselves. So in terms of the example illustrating those 2 points, if we look at 0, 1, 0, 4, 1, 0, 4, 1, maybe 0, 3. Here was a simple example of an object with a set of key value pairs, this being a key, this being the value, and so on. A key value pair combination we refer to as a property. So the me object here has 1, 2, 3, 4, 5 properties. And we also talked the last day about how we actually reference particular values within the array using either the dot notation or the subscript notation. So I think we're all fairly au fait with that. Just by the way, so if we just take this property here, this is the key and this is the value. We can actually enclose, like internally, the keys are actually stored as strings. You don't necessarily need to know that, but that is the case. And that's why we have the subscript notation, as in, do we have an example over there? We don't. You know, if I instead of going me.name there, I could go me subscript. Okay, that's essentially a string. Something else that I didn't mention the last day about JavaScript is that strings can either be single quoted or double quoted. So this string here, I'm using single quotes. I could have just used double quotes, and they're pretty much interchangeable, really. The only case when you might have to use one over the other is if you look at this example here, because this string has a single quote as part of it, then we need to wrap this particular string in double quotes. If I wrap this string in single quotes, then I'm going to get a runtime error because it now thinks that this quote is terminating this single quote and it can't interpret that. But other than that, single quote, double quote strings are completely interchangeable. Now, to go back to keys though, we have this subscript notation, and so the way we specify the key is to make it into a string. And the reason that really works behind the scenes is because these keys here are actually stored as strings internally in the runtime. And I could even declare these using the string notation. I could wrap that in single quotes and it's still going to be fine, or in double quotes, it's going to be fine as well. It's all still going to work okay. And the reason that is because, as I said, the keys are actually stored internally as strings anyway. We don't tend to though, we just tend to declare them in the way that I have down here. It's just less typing, I guess, as much as anything. In terms of nesting, this was the example that we had. So we can see here in this one, the well, there's two things going on here. If we just take the finance property, for example, which is a property of me, this is the key, and its value is a nested object. Okay, that's one illustration. There's something else going on up here in that I'm declaring an object here called name, and inside the me object, I'm actually referring to that variable. So that's really, I mean, all that happens at runtime is that the name variable gets substituted with the actual object that it's assigned to. So it's just one level of indirection. The comment here is that since ECMAScript 6 or 7, I'm not sure exactly which one, there's so many changes happening in the language though, but if you've ever got that kind of situation, you can actually abbreviate it to just that. Okay, that still works fine. The runtime is intelligent enough to work out that what you're trying to say here is, I want to have a key where the name of the key is name and the value is a variable called name, which it finds from up here. And so it's just a shorthand really. You'll see me using that every now and again later on in the course. But for now, I guess it's easier to interpret that approach. That's nesting. And then we have illustrations of how when you do have a nested object, and indeed there could be further nesting going on inside here if you wanted to, then to try and access any particular part of the inner object, we simply navigate down to that part. By navigate down to it, I mean we start with the me object, then we reference the finance property within that me object, and then we reference, let's say, the amount property within the finance inner object. I think I have that going on here. Yeah, I'm just following the same principles of the dot notation to delve down into the inner objects. And again, we can mix and match the subscripting and the dot notation as much as we want. And I covered all that the last day, I think. Just pause for a second if people have any questions. No, everybody happy? Good. Right. Just some other little odds and ends, really. There were some new extra kind of features added into the JavaScript language. Again, I think it might have been around ES7, which would have been around 2016. So for example, one thing is sometimes you may want to get all of the keys in a particular object for whatever reason. And so we can do it using this syntax here. Okay, so there's a special kind of global object called object, which has a method called keys. And if you pass it a reference to an object that you have, then what keys will return is an array of strings where the strings are the names of the keys in this object. Equally, you can get at all of the values in an object using this approach here. The in property is nice. It's not a property, the in operator allows you to express a condition test where you want to check whether an object has a particular key or not. Sometimes you might have a method that receives an object, and because JavaScript is dynamically typed, then there's no guarantee that that object is of the right type that you want. So the only way you can prove that is perhaps by checking to see, does the object have certain properties? And if it does, then you're happy to continue on processing that object. Otherwise, I guess you throw an exception, or you reject it in some way. So this kind of expression here, where me is the object that I was showing you there a while ago, this kind of expression is going to evaluate, in my case, to true, the Boolean true, because me did have a key called name in it. So we've got illustrations of all of these in 042. So if I change my just going to close off these. Okay, so name as before, me, etc., etc. And if we see here, I'm saying I'm trying to access all of the keys in the me object, and then I'm doing a console.log of keys, which is returned. Keys now is going to be an arrays. I'll talk about arrays in a minute, but you know, there's no surprises. Arrays we're familiar with, but just to see what happened in my, that's not right. Let's see. Maybe I need to restart it. Did I save everything? Too many files open here now. Index. Yeah, is my server running? It is, but let's kill it and start it again. Right, it's a bit better. So this is the array, and there are the keys in the me array. So that's that console.log, and down here I'm just illustrating the accessing all the values. So let's see, how does that look? These are the values, I guess. And again, they kind of tally with what's in the me array. And you can explore that yourselves later on. Finally, I'm illustrating the in operator. So this console.log should output the Boolean true, because me does have an address property, whereas this should output the Boolean false. And that's what I get. Okay, so there are just some odds and ends really related to objects, and I think maybe I've told you about these particular ones because we use them later on, but there are some other aspects as well related to objects that we may touch on later on that I haven't covered here. The last point on this slide, I've already mentioned to you the fact that internally the keys of an object are always stored as strings, whether you declare them that way or not. That's how they turn out. Next, we have arrays, and arrays are the same as arrays in any other language. I should say that in an object, there's no sense that we have the first property, the second property, the third property. Properties are not in any particular order. The opposite is true of arrays. Order is very important in arrays, as we know. So an array is an ordered list of values, and the values can be of any type. So you could have a mixture of different types within an array. Now, that might reflect a poor design, though. It's probably not good design to have different types within an array, but the language allows it, unlike in Java, where you have to declare what are the types of the type of the various elements in an array. It doesn't apply to JavaScript, but it's probably frowned upon really from a design point of view. And we use the subscript notation to access particular elements within the array, which is the exact same as any other language. That's what I'm saying at the bottom. And we're told to look at sample 05. So you know the drill at this stage. I'll disable that. And have a look at 05. And again, nothing terribly interesting. So I'm just doing, here's my array console.log here. I'm using the subscript. Again, it's indexes begin at 0 and all of that. So console.log of nums2 should output a 5. And I guess that's what we get. Yeah, that's what we get at the top there. Then I am showing you here how you might iterate over an array using a standard loop. However, you'll see that we hardly, in fact, we never use this type of loop to iterate over an array. There is a much more JavaScripty approach towards iteration, as we'll see later on. But for now, that's just your standard for loop, which you've seen many times before in Java and other languages. And it does what you think it should do. So it's generating this output here. There is a slightly more elegant syntax, which is here. So this is an alternative to this for loop. So it's what's called the for of, is it? Yeah, the for of loop. And again, it does the exact same. It iterates over the array. There is a much better way of doing it, though, which we won't see in this script, I think, but we will see it later on. What else about arrays? Oh yeah, I'm telling you this here, but it won't, it's something that you shouldn't really dwell upon, but it turns out that like many languages, most languages have arrays natively supported within the language, but in fact, JavaScript doesn't. The only data structure that JavaScript supports natively is the object structure. But we can use arrays, and it turns out that arrays are actually converted into objects internally. Now, knowing that is fine, but it's not really that useful, but it is the case. So in fact, you know, where I wrote, if I go back to my script, where I wrote nums subscript 2 here, I can actually change that to the string 2. Okay, and that now looks like object subscript notation, and it's still going to work because if I flip over to the browser, you know, it's still giving me the 5. And that's because internally, this array is actually stored as an object where the keys are the key 0, the string 0 is assigned the value 12. The key 1, the string 1 is assigned this value, and so on down along. So that's what actually happens deep within the JavaScript internals. Given that an array is actually an object, but because you have declared it as an array, it does get some extra properties as well. The runtime takes care of that. So it adds a length property. So you can write an expression like this, and that does what you think it does. It returns the length of the array. And then there are various, what I'm calling utility methods associated with the array type that allow you to add and remove elements to and from the array. Typically, you might want to add an element to the end of the array or remove an element from the end of the array. To do that, you use the push and pop methods. If you want to add or remove an element from the start of the array, you use the shift and unshift. And there are various other methods as well, like if you want to join two arrays, etc., etc. So there are these various additional attributes of an object array that you won't get with an ordinary object. And I think I'm just illustrating some of them. So if we look here, so this is demonstrating the push and pop operations. So when I go nums.push 10, I want to add 10 to the end of the array. So when I do my console.log here, I would expect to see the 10 at the end. Do I get that? Yes, I do. Here's my 10 at the end. Here I'm illustrating the pop operation to remove the last element. What the pop method returns is the element that it has removed. So popped here should be 10 again, because I've just put 10 at the end. And so when we look at what these console.logs output, we get, yeah, so this is the array after you've done the pop. So the 10 is gone, and this is the value that has been removed or popped. And I demonstrate the shift and unshift down here, which again, you can probably just look at yourself, but just very quickly. So unshift, oddly enough, unshift is to add something to the start of the array. Shift is to remove it. And so it looks like I want to add 3 to the beginning and then remove it. And that's what's happening down here. Here's my tree pushed on, and then my tree after it has been removed. Okay, so that's just some odds and ends about arrays. Just going to pause for a second now. Any questions? Okay, so I mean, we're all familiar with arrays, so excuse me. I wouldn't have expected anything really. And so with those two constructs, arrays and objects, really you can describe any type of data structure that you want. They're really the only two that you need to describe anything. So you can have nesting of arrays within object within arrays, etc., etc. And you just follow in terms of trying to navigate a very complex data structure. You just got to remember the first principles of with objects using either the dot notation or the subscript notation. With arrays, you just use the subscript notation. You know, so if you've got an expression like I'm saying here, if you've got an array where elements are also arrays, then an expression like this is going to work. And again, you would have seen this, my guess is, in other languages. So we're accessing the fourth element in our outer array. Now that expression, array outer subscript 3, that expression evaluates to an inner array and then we're indexing into that inner array. Here I'm saying, for example, suppose you've got an array of objects and you want to refer to a particular property within one of those inner objects. Okay, so this expression here, that's going to evaluate to one of the objects in my array. And so it's followed by the dot notation to access a particular property within that object. And finally, this example, I've got an array with a property whose value is, I've got an object with a property whose value is an array. So this expression here, that's going to evaluate to an array, and then the subscript 5 is accessing a particular element within that array. So as I say, it's just a question of following the first principles of object manipulation, array manipulation. And you're probably going to get it wrong a couple of times, certainly if you're digging down into a very complex data structure. But try and follow the first principles. Finally, we have seen strings up to now, but they've been very basic and static. And also we've seen that, we've had a console.log that that used string concatenation, which is what's kind of going on here, right? And really writing this kind of code is very error prone, because if you leave out one of the quotes, it can't be interpreted properly. So it's quite buggy kind of code to write. And because of that, and also because other languages have something called string templates, then in ES6 JavaScript introduced string templates. And so what a string template allows you to do essentially is to embed variables within a string, and those variables get evaluated, and the result of the evaluation gets added to the string. In fact, it's even more powerful than that. You can actually embed an expression within a string. And by an expression, typically it might be you actually call a method of an object, and whatever that method returns, that's what gets embedded into the string. So we just take this example here. This is kind of an alternative to what I have up here. Now we're assuming that foo 1, 2, 3, 4 are just primitives in this case. Now it does look quite long-winded. The things to note are, this is not a single quote. This is actually the back quote. It's a special character. And then wherever you want to embed your variables in your string, you've got to wrap that variable in this $ curly braces wrapper. Okay, so use the back quotes to encapsulate your string template. We refer to this as a string template. I'm saying that interpolation is going on within the string template. By interpolation, we mean it actually evaluates what's within. It evaluates what's within this expression here. And as I've already said, you can have any kind of complex expression that you want to in here. You could have an arithmetic operation, you could call a function, etc., etc. Also in ES6, they introduced multi-line strings. We don't use them that often, but they're there anyway. And finally, we just look at a quick illustration of all of this. So here's my illustration. I've got, so this constant has my height in old imperial system using feet and inches, so 5.9 feet, Maria. We haven't seen functions so far, but you could probably kind of work out what this piece of logic does. What I'm doing here is I'm going to talk a lot about functions in a while now, but the idea of this function is it takes a measurement in feet and inches, and it, well, in feet really, and it converts it to meters, to a metric equivalent. So it's just doing a calculation. But either way, its term meter is actually a piece of logic. And here I have my string template, my back quotes. On D, I'm inserting the name variable into my string. And over here, then I'm actually calling the term meter function, passing it a value. And so that entire expression gets evaluated. And the result of the evaluation, in other words, whatever is returned here, that gets inserted into the string. So when I do the console.log of text, what do I get? I get all of this. Yeah. So that's template strings. Here I'm just illustrating a multi-line string. So you've got your back quote to begin it and the back quote to end it. If it's a multi-line string, you do have to actually wrap it in parentheses as well. And again, similar type of interpolation going on inside here. And so what the console, when I do a console.log of that, I get this stuff here. And I've kind of already mentioned this, right? But, you know, within your string, you can have single quotes, double quotes appearing as well. So string templates really you would have come across before, I'm pretty sure, certainly in Java and other languages as well. So nothing really new there either. Going to pause for a second. Any questions, I wonder? Are you still out there?
Yep.
Yeah, good. Right, that's everything I want to cover in relation to data. Now I want to move on to behavior or logic. How do I represent logic in JavaScript? And the answer is we use functions. So where objects are the unit of composition for data, functions are the unit of composition for logic. And again, we have the kind of pre and post ES6 eras. In pre-ES6, which I'm just calling ES5 there, ECMAScript 5, there were two ways you could declare functions using function declarations or function expressions. And we'll see these in a second. And JavaScript had this odd kind of characteristic called hoisting. Not really too sure why Brendan Eich made it part of the language, but it was there anyway. It's kind of being covered up now, but just to make you aware of it, the idea of hoisting was that within your JavaScript file, you could have a piece of code that invokes a function before the function is declared within the file. So you could have a function declaration at the very bottom of your file, but higher up in that file, you would be actually invoking the function. So that kind of seems odd that you could invoke something that hasn't been declared yet. And the reason that actually worked was because at runtime, all of the function declarations within your file were actually hoisted to the top of the runtime environment. And so that made sense then that you could actually invoke it because of this hoisting. But hoisting really isn't an issue anymore, but it's something you may come across if you're reading about JavaScript at all. So ES5 has function declarations, function expressions. We'll see examples of those in a second. ES6 introduced what are called arrow functions. And really arrow functions are a cleaner kind of syntax for writing either function declarations or function expressions, which we'll see. And also we have this notion of anonymous functions. Anonymous functions have been part of JavaScript from day one. An anonymous function is a function that doesn't have a name, which may seem odd. How can you invoke a function if it doesn't have a name? But it turns out that we use anonymous functions an awful lot in our code, and we'll see how that turns out in a few moments. Now, there's a separate set of samples accompanying all of this function related stuff, and you will get the samples in if I go into, you get the samples associated with this lab here. But for now, I'm just going to import the samples into my JavaScript. And it'll be the same as before, really. We'll have an index.html referencing various sample script files. And we'll just step through them one by one. So here's my index.html. Again, the important part is going on down here. So if we take the very first script, 01, so I've got some objects. I've got the me object, I've got the her object, and I've got the here object. So I'm going to be using those in my functions. That's the idea. So let's start off with function declarations. And so this is what the syntax looks like. So there's this keyword function, the name you want to give to the function, parentheses encloses the parameters, and then the curly braces encloses the body of the function. This is a very simple function. It just has one line of code in it, but obviously you could have any amount of logic that you want to. My idea of this function, just in terms of what it does, the idea is it receives an object and it tries to determine whether that object is a person or not. And I've just decided kind of arbitrarily that an object is a person if it has a name property and it has a gender property. Okay, this is obviously the logical AND operator in JavaScript. So if this entire expression evaluates to true, then the object that I've passed in is a person object. Okay, and here I'm just invoking it. So I'm invoking my function, passing in me. So I would expect that console.log to return true. I would expect this console.log to return false, because here doesn't have, it has a name, but it doesn't have a gender property. But just in terms of functions anyway, that's what we're really interested in here. This is what we call a function declaration. This has been part of JavaScript from day one. But just let's make sure it does what I hope it does. So the true and the false, yeah, that looks right. That's function declarations, declaring it and then invoking it. Function expressions, what actually you can do is, here I'm declaring a function. I'm not giving it a name though, but I am assigning the function to a variable. And now the variable name becomes the function name. And it doesn't have to be const, but I guess it would make sense that it is const, because we're not going to be changing the internals of the function kind of at runtime. But from a syntax point of view, this is what we call a function expression. And the rest of the function syntax then is the same as before, as in you enclose the parameters of the function using the parentheses, and you enclose the body of the function using the curly braces. In terms of what this particular function does, the idea is that you pass it a person object and a string, and what it's meant to do is the string is meant to be a middle name for the person. So the first thing I do in the code is I check to make sure that the first parameter is actually a person object. Otherwise, I throw an exception. So in passing here, I'm actually showing you how we throw exceptions in JavaScript. And here then, what I'm doing here actually is kind of the old way of checking to see whether an object has a particular property. So person.name.middle, I'm checking to see, is that equal to undefined? Now, if I look at one of my samples here, right? Here's the me object. It has a name property, but within that name property, it doesn't have middle as one of its inner properties. So it looks like this person doesn't have a middle name, whereas this person here does have a middle name. So in my function, I'm just checking to see, does the person currently have a middle name property? And if they don't, then simply kind of create it or add it. Whereas if they do, then I want to extend their middle name by whatever has been passed in. This is really kind of the old way of checking to see whether an object has a property. By old way, I mean, a few moments ago there, when I was talking about objects, I said we could use the in operator to check to see if an object has a property. And so a slightly more modern way of writing this, but the reason I actually wrote it this way is because you will see it in any kind of code that you might read. But the slightly more modern way would be to go middle in person.name. And really what I want to check for here is if the name is not in it, so I'll not that operation. And I'm going to wrap that to make sure the order of evaluation is correct. So I think that should do the same. Middle in person.name. Let's see, did I make a syntax error? No, I didn't. Or did I? Sorry. No, that looks fine. Okay, so check to see if person.name has middle in it. If it doesn't, do this. If it does, do this. And then I just arbitrarily decided to return true. So in terms of calling this function, then because it throws an exception, I'm wrapping the call in a try-catch block, which you've seen in Java. And I'm just calling it a couple of times. I'm calling it with me, passing it in Stephen. Now we know that the me object doesn't currently have a middle name, but when I do a console.log of, sorry, I also do it with her. Sorry, I call it here and I call it here, and then I do a console.log of me.name, and then I do a console.log of her.name. And so the console.logs are being outputted here. So we can see that I didn't have a middle name, and it just adds that property, whereas her already had a middle name, and we just extended it with 2 parts to the middle name. Okay, what the function does isn't terribly interesting, but the key illustration here is this idea of a function expression, the idea of assigning a function to a variable. That's a very powerful characteristic, because if we can assign a function to a variable, then that means we can actually, and variables are things that we can pass around. We can pass a variable into another function. So that gives us the ability to pass a function into another function. And that's something we'll talk about a little later on. And it is something that you see an awful lot of. And that is possible because of this idea of function expressions. It's essentially the same as lambdas in Java, but function expressions have been part of JavaScript from the outset. Lambdas, as we know, was only introduced into Java more recently. So that was one thing that JavaScript had that Java didn't. Any questions about that example? Now, there was something else in that little example in passing that I just want to highlight as well. So if I just undo all of those changes that I made. You can see here we've got what's called the triple equals operator, and that does what you think it does. It compares what's on the left to what's on the right to see if they're equal to each other or not. JavaScript also has the double equals operator, which essentially does the same thing, but it's not as safe an operator as the triple equals one. Technically, the difference is that the triple equals operator does 2 things. It first of all checks that the thing on the left is of the same type as the thing on the right. And if they're not, then it evaluates to false. If they are of the same type, it then compares their value to determine true or false. Whereas the double equals operator, it's not as fussy. It just does a kind of basic value type comparison, even though the types might be different. And that's considered a less safe operator. The original JavaScript had only the double equals operator, but in one of the more recent ECMAScript specifications, they introduced the triple equals operator to essentially avoid the bugs that are associated with the double equals. So in short, don't ever use the double equals, use the triple equals also, always, sorry. Anyway, that's function expressions. Next, we are illustrating arrow functions. Arrow functions were introduced in ES6, and really arrow functions are a slightly cleaner form of function expressions, I suppose. Because here's an example, right? Here again, I'm actually declaring a function and I'm assigning it to a variable, just as before. But the keyword function isn't appearing here at all. But because I'm using this arrow, hence the name arrow functions, what I'm actually declaring here is a function. So to the left of the arrow are the parameters of this function. To the right of the arrow is the body of the function. And again, we use the curly braces to encapsulate the body, and we use parentheses to encapsulate the parameters. In the case of this little function, I'm again passing it in a person object. And again, as before, it checks to see, is it actually a person object? And if it is, then it determines, is the person, well, maybe I should explain what's going on here. In general, what the function does is it determines whether the person is male or female. And depending on their gender, then it returns a string that either begins with Mr. or Miss, followed by their name. Okay, that's the idea. Maybe we should see it working. So if I go console.log salute me, what does that return? that returns Mr. Dermot O'Connor. Whereas if I do console.log of her, then it returns Miss Sheila Fleming. In passing, I am using what's called the ternary operator, which is here. Ternary operator is also available in other languages. You may have used it already in Java, for example. The way the ternary operator works is you have a Boolean expression, and if that Boolean expression evaluates to true, then what follows the question mark is what is assigned to the variable on the extreme left, title. If that Boolean expression evaluates to false, then what is assigned to title is what is after the colon. So the question mark and the colon are combined as part of this ternary operator. Really, it's kind of a shorthand for an if-else statement, where all you want to do in the if-else statement is determine a certain condition and assign something, A or B, to a variable, the A or B being Mr. or Miss in this case. Again, you'll see me using that ternary operator quite a bit later on down the line. The key focus, though, is this idea of arrow functions. And here is my declaration of an arrow function. That's the syntax for it. Is there any question about that? Because I think that's a little bit less obvious than the old ways of declaring functions. No? Now, there is actually a shorthand version of this. Sorry, the function goes all the way from here to here, my mistake. There's actually a shorthand version of the arrow function, and the shorthand version is used if the body of your function has just one line of code in it, and that line of code is actually its return value. And that's something that we do every now and again. So down here, I'm giving you an illustration of this shorthand arrow function syntax. The example in this case, I want a function that just needs to determine whether a person has a middle name or not. I don't care what it is, just do they have a middle name or not. So this function is going to return, I want it to return true or false. So the first thing we notice is that this function only takes one parameter. So if you have an arrow function that takes only one parameter, you don't have to use the parentheses. Up here, I use the parentheses, but it actually turns out I didn't have to because there was only one parameter. If there's more than one, then you do have to use them. So we can optionally drop the parentheses. Secondly, previously I said that we enclose the body of the function in curly braces, but there are no curly braces here, and that is because this function only has one statement in it, and that statement is its return value. So I don't actually have to use the curly braces to wrap the body. I've also eliminated the return keyword, and you can drop the return keyword if the single expression in your function is actually the return value of that function. I can still put in the return, but if I do put in the return keyword, then I must also use the curly braces. Okay. So this is really the shortest possible form of the arrow function that you can write, where a lot of the extra noisy kind of syntax is gone. And so what it's doing is just validating the person, checking that the object that was passed into it is actually a person, because we know this function returns a Boolean true or false. And we're also doing a logical AND to check to see, does the person object have, does person.name have a property called middle? So that entire expression either evaluates to true or false, which in this case, this is what I want my function to return. This shorthand form is not limited to functions that just return Booleans. It can return any type it wants to. Happens to be a Boolean in this case. Now, when we start embedding these shorthand arrow functions in our code, it does get a little bit tricky following the flow of the code. But this is the simplest form that I could come up with as an illustration. And here I'm just calling it as before. So without laboring it, if I really wanted to do it the long-handed way, I'd have to put in my curly braces. I need to use the return keyword here. And, use the parentheses here. I guess initially you're probably better off using the longhand form, using this style here. And then once you start getting comfortable with the syntax, you can start adopting the shorthand arrow function form syntax if it's appropriate. It only works for functions that have a single statement in the body. Any questions about that, I wonder? No? Okay, let's move on. So that's just in text form there, what I've been saying about arrow functions and the shorthand form of it. Now, I'm just mentioning here about something called constructor functions. So just to backtrack, the original JavaScript does not support classes. But this idea, classes are obviously a really nice feature of a language because it allows you to easily create multiple instances of a particular type. So for example, it would be nice if I could declare a person type in my code and then create multiple instances of that type using some sort of function to do it for me. I had to encode me and her as literal objects here. And so, if I wanted to create multiple persons, this just really becomes very long-winded. So for that purpose, or for that situation, the original JavaScript had something called constructor functions. And I'm just mentioning them here, okay? And a constructor function really has the same purpose as classes in more modern languages. More than that, I'm not going to go into because we won't be using constructor functions. Constructor functions have been overtaken by classes in JavaScript. ES6 does now support classes, but really when your class syntax is transpiled or converted back to ES5, what you would notice is that the transpiled code is actually using these constructor functions within them. but I'm just mentioning them here for completeness rather than going into them in any detail, because as I said, we won't really be using them. So you can read up on them if you wish. I am mentioning one or two other kind of programming terms really that kind of are relevant to JavaScript, but they're relevant to other languages as well. One programming term that we often talk about are side effects. Does a particular method or function have side effects? Side effects are where a function or method makes some changes outside of its scope. The scope of a function, of course, is whatever is within the curly braces. The scope of a method in Java is whatever is within the curly braces of the method declaration. So side effects can apply to any kind of language. And the idea is if a method or function changes some data outside of its scope, then we simply say that that function or method has side effects. In fact, side effects is a little bit broader than that. Even if a function or method does some output to the screen, then the output to the screen is essentially a side effect as well. It is something that happens outside of its own scope. So for example, if you think of these functions that I've just gone through there, the add middle name function has side effects because it was passed in a person object, but the person object was declared outside of its scope, but it was actually able to change the name property of that person object. So we would say that add middle name does have side effects. The salute method, or function, sorry, if you can remember it, it didn't have any side effects. It didn't cause any side effects. It didn't make any changes to the person object that was passed into it. It returned a string using the person object, okay, but it did not change it. Hence, it doesn't have any side effects. There is this area of programming called pure functions, or sorry, there's this idea of having pure functions in your code. And a pure function is a function that has no side effects. And it's considered a good objective to try and have as many functions within your JavaScript code that are pure. It's not easy to achieve, but it's just something that you need to be aware of. But I'm mainly kind of giving you some terminology here rather than, like, I won't necessarily be looking at your code to see how many pure functions have you written in your code. That's not the idea of this module at all. But I'm just making you aware of these terms, and they're not just related to JavaScript. They are related to programming in general. And in that vein, there is a whole area of programming called functional programming. And the idea of functional programming is that all of your functions and methods are pure functions. And it is possible to write applications that are solely comprised of pure functions or pure methods. In fact, any of the students that are studying the BSc applied stream that are on this module, in fourth year, you will be doing a module called functional programming. So we will be going into this whole area in much greater detail. It's not really a concern for this module. As I said, I'm just making you aware of these terms. Now, we have this notion in JavaScript of what are called higher order functions. And it's really important now that you kind of grasp this, because an awful lot of the code that we will see and write will adopt these higher order functions style. So what is a higher order function? Higher order function is a function that takes another function as a parameter. So you pass a function into another function. And I guess the idea is that the function that is being invoked will actually call the function that is being passed into it. The function that is being passed in, we refer to as a callback. So you could have syntax, and I'll leave it at this bit because I think we're towards the end of our lecture. This kind of idea here where I'm just using function declarations here. I'm declaring a function, and one of the parameters of this function is going to be another function that I'm passing into it. And the general idea is that somewhere within the body of this function is actually going to invoke the callback within it. So the next day, we're going to look at some examples of higher order functions in relation to arrays specifically. But as I said, higher order functions are kind of all over the place, and you can't avoid them when you're doing JavaScript programming. So I'm going to leave it at that for now, and I will pick up the story on Monday unless there's any questions at the, that you have remaining. No. Okay, so we'll leave it at that, and I'll talk to you again on Monday.